Yeah, good day, viewers. We have this question on thermal physics, a quick one. What does it say? The question says a piece of copper of mass 300 gram at the temperature of 950 degrees Celsius is quickly transferred into a vessel of negligible thermal capacity containing 250 grams of water at 25 degrees Celsius. Now, if the initial steady temperature of the mixture is 100 degrees Celsius, calculate the mass of the water that will boil away. All right, so we are given the specific heat capacity of copper, which is 4.0 times 10 raised to the power of 2. Specific capacity of water is 4.2 times 10 to the power of 3. And specific latent of vaporization of steam is 2.26 times 10 raised to the power of 6. Right, so now to do that, we have solution. We have copper. That's a chemical symbol for copper that has a mass. The mass of copper has been given to be 300 gram, and that converted to kilogram, that is 0.3 kilogram. And also we have its temperature. The initial temperature of the copper has been given to be 950 degrees Celsius. All right, so now we were told that was quickly transferred into a vessel of negligible thermal capacity. So the vessel has a negligible thermal capacity. However, the vessel contains water. All right, then we have water, which is the second substance. Okay, now the mass of water that was given is 250 gram. Now we'll convert that to kilogram. That is 250 divided by 1000, which is 0.25 kilogram. And its initial temperature, okay, is 25 degrees Celsius. That is the initial temperature of water, which is 25 degrees Celsius as given in the question. Now we were told in the question, as the question proceeds, if the final steady temperature of the mixture is 100 degrees Celsius. Now if the final steady temperature, that is when you mix, when the copper has actually been transferred into the vessel containing water, so there is a temperature which is known as the temperature of the mixture where the two substances will meet. So the temperature of the mixture has been equal to 100 degrees Celsius. That is when this copper has been quickly transferred into the water in the containing vessel. Now the question proceeds and says we should calculate the mass of water that will boil away. Okay, the mass of water that will actually boil away is what we are asked to calculate. All right, so now the initial temperature of copper was 950, which was very hot, and then transfer into a water that has initial temperature of 25 degrees Celsius. So definitely the copper must have lost some of its own temperature to this. So now the temperature of the mixture has been given to be 100 degrees Celsius. Now water has changed from its own initial temperature to 100 degrees Celsius. The copper has also changed from its own initial temperature from 950 to 100 degrees Celsius. So now some water will boil off. That is, if this temperature is to change to steam. This is ordinary water at 25 degrees Celsius. It has changed to water, hot water, at 100 degrees Celsius, and then also to water in the form of steam. Okay, water in the form of steam or vapor at a temperature of 100 degrees Celsius as well. So now, when copper changes to this form of water, the temperature is 100 degrees Celsius. So from 950 to 100, there is temperature change. And when there is temperature change, the formula to use is Mc change in theta. That is the quantity of heat. Now from here to here, there is also a temperature change from 25 degrees Celsius to 100 degrees Celsius. So we also have Mc change in theta when there is temperature change. However, from here to here, there is no temperature change. So now we should have latent heat. So there is 100 here and then 100. Water changing from 100 degrees Celsius to steam also at 100 degrees Celsius. So now the formula to use in this Y is ml when there is no temperature change. Now we should know very essentially that heat loss by copper metal will be equal to heat gain by water. All right, now what is the quantity of heat loss by copper, which is Mc change in theta? Mc change in theta, that is the heat loss by the copper, which is equal to the heat gain by water. So the heat gain by water is Mc change in theta plus ml. Okay, so heat gain by water is Mc change in theta plus ml. All right, so now this is for copper, while this is for water. Now the mass of copper, which is 0.3 multiplied by the specific heat capacity of copper, has been given in the question to be 4 times 10 raised to the power of 2. That is the specific heat capacity of water, which is the same as of copper, which is the same as 400 joules per kilogram per Kelvin. So 0.3 multiplied by 400, and the temperature change is 950 minus 100. All right, that is the initial the final temperature minus the initial temperature. Okay, sorry, the initial, that is for copper, so which is equal to mass of water, the initial mass of water, which is 0.25 kilogram, times specific heat capacity of water has also been given here to be 4.2 times 10 raised to the power of 3 in standard form, and which is equivalent to 4,200 multiplied by the temperature change. So therefore the temperature change here will be 100 minus 25. 100 minus 25. 100 minus 25. Let's put that in bracket. Plus the mass of water which has boiled off, which is ml. All right, multiplied by the specific latent heat of vaporization, because it has changed to steam. So, and the value has been given as 2.26 times 10 raised to the power of 6. Okay, so I'm going to write that in standard form, which is 2.26 times 10 raised to the power of 6, not minus 6, times 10 raised to the power of 6. So we have to start solving from here. We have 0.3 multiplied by 400 multiplied by 950 minus 100, which is equals 850, equals 0.25 multiplied by 4,200 multiplied by 75, plus this 2.26 times 10 raised to the power of 6, that is 2,260,000 multiplied by m, so that m is what we're looking for. So we're going to solve for that particular m. 102,000 equals this, which is 78,500 plus 2,260,000 all right, so we have to collect like terms, and we have 102,000 minus 78,500 equals 2,260,000 all right, so when we subtract this from this, then we find out that this is 23,250, and subtraction equals 2,260,000 So we divide both sides by 2,260,000. So the value for m will therefore be 23250 divided by 2,260,000. So this cancel out this, and we have our m to be equal to 0.01029, okay, kilogram. That is the value for our m. That is the mass of water that actually boils off, okay? Or we convert that to kilogram, and that is, to gram. That will be 10.29, okay, 10.29 gram. All right, thank you.